So we've seen how we do the basic differentiation when we have an integer power. But let's have a look at how we deal with non-cardinal powers. So something like this, y equals 1 on x. So I'll do it by first principles, and that way we can create our formula. So function x will be 1 on x. So function x plus h, 1 on x plus h. Sub it into our formula. Okay, let's play around with this. We'll get a common denominator of h, x plus h. So the first fraction, what's different? So it's just x on the top minus the second fraction, it'll be x plus h, so minus all of x plus h. The x's cancel. Now that gives us our situation of 0 on 0, so we can't substitute in yet. So we cancel the h's, and now we can substitute 0 in for h, and we end up with minus 1 on x squared. Now, if we did it via indices, we just changed it to the power of negative 1 and used the rule we already know, you'll see, well, that works fine. So I've proven it via first principles, but indeed we can still use the same idea of bring that power down, subtract 1 from the power. It's going to work for negative indices as well. So let's have a look at fractional power. So we'll do the square root of x, see if the same thing applies. Function x is the square root of x. So function x plus h, square root of x plus h, sub it into our formula. So this time, instead of we'd normally rationalise the denominator, this time I'm going to rationalise the numerator. So on the top I get x plus h minus x, which of course is just h. But again we have our situation of 0 on 0, but we can cancel the h's, so that's fine. Now I should be able to substitute h in, and we get 1 on, well, root x plus root x, which is 1 on 2 root x. So had we done it with indices, then I would have said, oh, well, a half comes out the front, subtract 1 from a half, we get negative a half, and so indeed we get the same answer. So again, proven it via first principles, but yes, we can still use the same idea of subtracting 1 from the power and doing that idea. So let's do some examples. So 3x plus 1 on x squared, change it to index form. Common mistake is to stop there because you feel like I've done some work. Okay, so there's more to do, of course, you've got to differentiate it. So 3x goes to 3, x to the power of negative 2, so negative 2 comes to the front, power is negative 3. Be careful with that, of course. Remember you're subtracting, it's so easy to go negative 2 and change it to negative 1, but you're subtracting 1, so it goes to negative 3. Yes, that's an answer. I always like to leave my answer in the form that they gave it to me. So they didn't use indices in the original question, so I'll change my second term there to be 2 on x cubed. So a mere mortal would leave the answer as 3 minus 2x to the negative 3, but us super mathematicians will write as 3 minus 2 on x cubed. I guess it depends what you're doing with the derivative. So if I'm just finding the derivative, yeah, all right, 3 minus 2x to the negative 3 is a perfectly fine answer. But if you're then going to find the slope of the tangent or something like that, it's probably easier to substitute in the 2 on x cubed, because you'll get that fraction straight away, depending on what the number is, of course. Sub it into x to the minus 3, it's not immediately obvious what the answer is. Okay, so x squared root x, change it to index form, so that's 5 on 2. So 5 on 2, x to the 3 on 2, when we differentiate, mere mortal answer, super mathematician. 5 on 2, x root x. But again, depending on what we're substituting in, like if I was just substituting in 1, it's not a big deal, because 1 to the power of anything is 1. But if I was going to substitute in 2, then 2 to the power of 3 on 2, well, your calculator is going to give you a decimal approximation. But if I've got it written as x root x, I can see straight away that that's 2 root 2. Again, I'll change it into index form, so we get 2, 5x plus 4 to the negative 2. So we'll use our rule from yesterday, anarchy, bring down the power. So minus 2 comes to the front, we get minus 4, lower the power, negative 3, diff the inside, 5. So we have mere mortal answer, minus 20, 5x plus 4 to the power of negative 3, super mathematician, minus 20 on 5x plus 4, all cubed. And it looks nicer too, don't you think? Yeah, lovely. Now this is where our rule from yesterday is really useful, because I've got to put it in index form, but I can't expand that out. I mean, how do you expand out x squared minus 3 to the power of a half? So that rule from yesterday comes in very handy. Bring down the power, lower the power. Now it's negative half. Diff the inside 2x. Half times 2x is x. Mere mortal. Super mathematician. X on the square root of x squared minus 3 as an answer. Alrighty. So, couple of exercises.